Alright folks, welcome back to the next lecture of physics. Today we're going to be doing a nice diagnostic exam of Newtonian mechanics called the force concept inventory. And hopefully I'll get to explain some of Newton's first laws, momentum, inertia, acceleration, all of that good stuff. We're going to look at over 30 problems, but before we even look at the problems, it's important to acknowledge where these problems come from. A lot of these problems are inspired by none other than our sponsor, Brilliant.org. Alright, so go ahead, go to Brilliant.org/BarryScienceLab, or just wait until the end of this video and click on that link for a free subscription. Alright, or 20% off, whichever one comes first. So make sure you wait until the end, and let's get started. So let's look at the first question. Two metal balls are the same size, but one weighs twice as much as the other. The balls are dropped from the roof of a second-story building at the same instant of time. The time it takes for the balls to reach the ground below will be. Okay, so let's take a look at the choices. So what do we have? First of all, we've got two balls, right? They're the same size, but one of them is twice as heavy. All right, so you can imagine that you got two balls. One of them is much heavier. Maybe it's made out of some dense metal, and the other one is made of who knows, plastic. Okay, but they're the same size. Now we want to know which one's going to hit the ground first. So let's look at the options. It's going to take about half as long for the heavier ball to fall as for the lighter one. Well, before we let the options distract us, let's think about the physics. If you've got two balls, it doesn't matter what their weight is, right? Let's say this one's weight is, let's say this one is m and this one is 2m. What time will they fall to the ground? What time will they hit the ground? Well, let's calculate it. Let's say that our acceleration is g, or 10 meters per second squared. Okay, so now we can just calculate this, what time it'll take. V equals VI plus AT. Remember, these guys are dropped from rest, so my VI is just going to be 0. So what's my time going to be? My time is going to be VF over A. Looks like I don't have enough to use this formula, but it says the balls are dropped from the same height, right? They're dropped from the roof of a from a single-story building. So let's say they're dropped from a distance of d. Okay, good. So now let's use this formula. D is equal to VIT plus half AT squared. By the way, you might be thinking, where did this formula come from? We're going to derive it in just a second. But before we do, let's try to find the time. So we know that both of these balls have an initial velocity of 0. So this term right here, VIT, that thing's going to go to 0. How about this? Well, remember, our acceleration is just g, right? So we can just solve for time here. Hopefully you see that our goal in this problem is to solve for this time variable. So let's do it. So what's my time going to be? It's going to be 2d over a, take the root of that, and that's going to be my time. Okay. And of course, what is my a? My a is 10 meters per second every second, or just g. Okay. Do you see mass anywhere here? Is there any m involved in this equation? Do you see mass playing a role proportionally or inversely in the amount of time it takes for the balls to drop? No. And in fact, this is extremely counterintuitive. In fact, as I'm telling you this answer right now, I don't believe in myself. It's that weird. But the fact of the matter is that both of the balls should hit the ground at the same time. Because as you can see, mass doesn't play a role in the amount of time it takes for the ball to hit the ground. Now why? Why doesn't it play a role? So the situation we have to think about is the ideal situation, right? Imagine for a moment that you had 0 air resistance. In fact, let's go to the classic example of the feather and the hammer. So right now I'm going to draw, or at least try to draw, a feather for you. So here we have a feather or a leaf, and let me draw that nicely. So here's my leaf and here's my hammer. Here's my hammer. So I drop both of these guys from the same height, and I expect that the hammer should hit the ground first because it's heavier, right? We have this common sense notion that heavier means it will fall faster. Heavier means faster, and so it will hit the ground first. It will hit the ground earlier. So we expect that this hammer will hit the ground at an earlier time than this feather. Maybe the feather is still floating away. Well, why do we say that? What makes us think that? Well, the fact of the matter is that the forces acting on both of these objects are the same, right? It's the force of gravity. You have Fg here and you have Fg here. Of course, the force of gravity makes all objects accelerate at the same rate, which is super weird. That's why our intuition doesn't make sense. It was proven that Galileo was correct. So let's see which one of our choices is matches that statement. So let's see. About half as long for the heavier ball as for the lighter one. No, we've just disproved that. About half as long for the lighter ball as for the heavier one. No, they should be the same time. The time for the balls to reach the ground below will be about the same for both balls. And indeed, that's the answer we're looking for. We're looking for choice C. Alright? Now folks, before you close this video, remember, wait until the end and click on that Brilliant link and subscribe to Brilliant, because without Brilliant, our videos wouldn't be possible. And yes, so make sure you support Barry Science Lab by clicking on that link at the end and subscribing. So we'll check you out next time.
Ambition plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.